So I've given myself this little setup here. As you can see, I've got a sphere and I've got a locator. And when I click on the locator, there's a user channel associated with it. It's a magic channel. And when I move the magic channel, it turns into a cube, into a sphere, into a cube. It's truly magical, only it's not. It's a bit more down to earth than that, obviously. As you can see, there's a cube and a sphere and the item list. There's two measure items. And all that's happening here, of course, is that this slider is modulating their visibilities. Visibility, of course, being one of the animatable properties in Modo. So if I go into the Setup tab, you can see that there's quite a bit of stuff going on here in the schematic view. I'm just gonna recreate this from scratch very quickly, just to not so much to explain to you how visibility and invisibility works, but it's more about working with conditional notes, because that's really how I'm going to connect the workings of this slider with the visibility of these two items here. So I've already got these notes in here, so I think it's pretty obvious how they got there. And I'll have a look at the conditional notes now. Now, as you can see, there's quite a few of them, but in reality these are all instances of the same node. So if I just take the first one and just go to the topmost drop-down menu under the properties, you can see that there's this whole list of different settings you can use, and really these all correspond with these. In other words, all you're doing is you just create different instances of the same node, but with a different preset here. But you can always change it over here fairly easily. The way conditional nodes work is pretty simple, it's pretty straightforward. It's really just the usual if then else type of construct that you can find in programming languages. You compare these two values. If the comparison yields true, then this is what's going to happen. If false, then this is what's going to happen. The topmost of these two is a drop-down menu. It tells you what exactly is going to be sent to the output here. You can either output value A, you can output value B, or you can output something called true value, and that's really just the value from this numerical input field. And same is true, of course, for this one. Now I'm going to use, in this case, both the numerical values from this and this numerical text fields. So I'm gonna basically what I'm saying is I'm gonna leave them set to output true value and output false value rather than outputting value A and B. And in reality I'm not going to use A is equal to B. I'm actually more interested in A is greater than B. So as soon as this slider is greater than 0.5, I want the cube to be visible and the sphere to be invisible. So let's set it to 1, and I'm going to be comparing the state of this slider with, in this case, a constant value. So as long as you haven't got anything coming into this input, you just use a constant value that you just type into this numerical input field. So if A is greater than B, then we want this cube to be visible. So how does visibility work? If you go into display, cube display possibly, you'll see that visibility is actually a drop-down menu. You may expect it to be a Boolean value, so true or false, yes or no, but in reality it's actually well, it's a whole list of values, and that's really what drop-down menus are. It's really just a list of values, and if you want to address or want to use one of these values, you just simply address it by its numerical equivalent. So starting with 0, you count 0, 1, 2, 3. So the default yes visible is 0, and not visible is 2. 0, 1, 2. And those are exactly the values I'm going to use here. So if the slider is indeed set to greater than 0.5, if the slider is pushed to the right, I want this cube to be visible, which is 0, that's correct. If it is not pushed to the right, if it is smaller than 0.5, I want the output value to be 2, invisible. So if I connect this now to the visibility of the cube, let's see what happens. Ta-da! As soon as it crosses 0.5, the cube becomes invisible and visible again. I'm going to do the same thing now for the sphere, but in this case I'm going to use less than or equal to b. That way I'm sure that at no point is there a gap, that is to say at any given time will either the sphere or the cube be visible. Otherwise, if I was to use just a as less than b, at the moment that the slider reaches 0.5, you wouldn't see anything there. That's not what I want. So again, I'm going to compare the state of the slider with, again, 0.5. Again, I'm going to output the true value, that is to say the information coming from this numerical input field. Again, the same as if it's true, this comparison, I want the sphere to be visible, otherwise it's going to be invisible. Make sure it's connected up to the visibility, and there we are. This should work now. Pop, pop, pop. Now as you can see, the conditional node also has got this output called result. A result is really just the Boolean value. That is to say, if this comparison yields true, out of this output you'll get the true as a value. If it's not, if the comparison yields false, then of course the output is going to be false. Now in reality, true and false turn out to be 1 and 0. So if you take this out and put it into another node, if it's true, this comparison, you'll get the value 1, otherwise you get the value 0. Now this is a more practical example of what we were just talking about. As you can see, I've got a very simple rig here. It's just an IK rig. But when I click on the locator here, you can see that I've got an FK-IK slider. And when I slide it, you can see that I've used a trick we were just talking about of making things visible and invisible. So now I've got an FK rig, and you can slide back into the IK rig. The one thing that's different from before is that there's an extra node here. So this is the node that we had before, which is really just deciding whether something is going to be visible, yes or no. In this case, the skeleton, the FK skeleton. And this node here in between is also a conditional node, but it's really just there to translate a Boolean value into values that the visibility understands. So I just did this really just to make it a bit more intuitive for myself, because intuitively you want visibility to be a Boolean value, 0 being invisible, 1 being visible, or false being invisible, true being visible. And that's really what this node does. So this allows me to just create the logic, if you like, on this side, and only be concerned with the logic of whether I want this skeleton to be, this part of the skeleton to be visible, yes or no. And this is really helpful as soon as you want this decision taking process to be more complex, which is what I'm about to do. Because what I want to do is I want to have an override that allows me to show me both the FK and the IK rig simultaneously. Most of the time I'm probably quite happy to work like this. When I'm working in FK, I'm quite happy to work like this. When I'm working in IK, I'm quite happy to work like this. But when I'm moving between the two, I may want to see the IK goal right now, if I know that in a few frames from now I'm going to be using IK. So I'm going to give myself an override. And the first thing I'm going to do is I'm going to add an extra user channel here, and I'm going to call it all visible, and I'm going to call it, it's already there. I was going to say it's going to be a Boolean, but it's already set to Boolean. And Boolean is really just an on and off switch. It basically comes in as a tick box, and you have to click on it again, and there it is. So I've got a little tick box that's going to be used as an override. And in order to make that work, I'm going to give myself a new conditional node, an OR one. And this one takes in two values, and if either one of them turns out to be true, it's gonna output a true value from the result. Now, as we were saying before, you can either output an output, or output a result, or you can use both, in fact. The result being just a Boolean value. So if I'm going to compare this output, the output from this node, to the state of this button, which is also comes in as Boolean, that should give me the logic I'm after. So if you want to understand this logic, the best way to do that, I found, is to simply read it out loud. So what we've got here is, if this slider is set to less than 0.5, or the override is switched on, we want the skeleton to be visible, the FK skeleton to be visible. So let's test that out. At the moment it's behaving like it was before. I switched the override on, and now the FK skeleton is visible all the time. All that's left for me to do is to apply the same logic to the IK goal, or again, this is the override. Let's bring it in, that's the override. I'm gonna pipe this result through this node, and there we have it. With the override switched on, both the FK and the IK rig are visible. With it switched off, only one is visible at a time. So there you have it, a bit of playing around with booleans and visibility. I hope that gives you some ideas to come up with some cool stuff yourself. If you do so, please let us know, and thank you for listening.